to explain a problem called minimum size subarray sum. And the idea here is that we are asked to find a subarray, which essentially adds its elements, and that the addition of those elements should be greater than or equal to the sum. Now, of course, there are many subarrays that have this quality where if you add them, they'll be greater than or equal to the target that was passed in. But the problem is that we want the smallest of all subarrays that meet that condition. So, this subarray is greater than or equal to 7, and this subarray is greater than or equal to 7. But there's only one subarray which has the smallest length of all of them, and it still adds to the sum, and so we want to find that. We begin by establishing a left and right pointer. This is a sliding window problem. And we also have a sum. So our sum begins at 0, and we have a variable to store our result. Now, while right is less than nums.length, so this makes sure that we can travel the entire array. And we choose right because right is essentially going to be traveling faster than left. While a particular condition is true or not true, we increase our window, and so the increasing window part will essentially be delegated to the right pointer. And so we're adding elements as we're walking R, or the right pointer, down the array. So we're adding elements. So for the first iteration, we say sum is equal to what sum was before plus what the right is pointing to in the nums array. And of course, that's just 2, because 0 plus 2 is 2. And then we move right up. Okay, we move right up. So we've executed this line, and then we move right up because, again, this whole block of code here is only to catch one case, which is the sum greater than or equal to the target? So as soon as our sum reaches that point, we're gonna talk about what logic should be ideally done. So again, we've moved right up, and we're going as planned. And we come back up here, and we ask ourselves, okay, well, is this condition false? Is this condition still true, which is right less than nums.length, which it is. And so we're continuing to add the elements. So sum is equal to what sum was before, which is 2 plus the 3 there. So we actually have 5. And then, of course, we shoot back down here and we add right up because it checks that the sum is not greater than or equal to the target yet. So we move right up again. And then we come back up and we add the number that we're currently looking at to the sum, which is 1. So we're currently at 6. This condition is not true yet for an input of 7. And so we increment right again, and so right moves up again. And as you can see now, when right moves up and it comes back up here, and then it says, okay, sum is equal to sum plus 2. So our sum was 6, and we've added 2 to that. Now our sum is 8. And guess what 8 does? 8 is greater than or equal to 7. In fact, it's greater than 7. And so we have found an array, a subarray that meets the condition that we wanted to catch. And so what we do is we introduce result, and we say, okay, result is going to store the smallest of all subarrays that has this condition. The length of the subarray that meets this condition, we want to store the smallest that we encounter. And so what we say is result is equal to what result was before, which was the smallest value that Java can hold. So the first value that meets the condition, it will store that that piece of data. So this is just the length of the subarray, okay? Because if you're looking at a particular right and you're looking at a particular left, if you subtract them, right minus left will give you the distance between the right point and the left point, and that's just in everyday life. If you started at 2 and you end at like 7, if you want to know how much you traveled, 7 minus 2, right? And same idea here. You take the right point minus the left point, the right point minus the left point. But you have to compensate for the fact that we're shifted by 1. We're shifted by -1 because your indices don't start from 1. They start from 0. So you have to compensate for that fact and add 1 to it. So your length is right minus left plus 1 of the subarray. So the result was the smallest value that the biggest value that Java can hold, sorry. And then so the first smallest value that for the first small value that it encounters will be set to result. And so naturally our result, I'll write this up here, our result is equal to 4 because 0, 1, 2, 3. So this indice is 3, and then 3 minus 0 is 3, plus 1 is 4. So it has captured the length of this subarray as 4. And what we do now is we actually want to find the next subarray that does not satisfy the condition. We want to just basically, we want to keep shrinking our window from the left until we don't satisfy, until the condition that, the sum is greater than the target. Until that condition is falsified, because we want to set ourselves up for finding the next best window. So we say sum is equal to what sum was before minus what the left is pointing to. So we're not only moving the left pointer up, but we're also taking away from the sum. So the sum is now going to be 6 as it was before. And of course, it jumps back up here and it asks, is the sum greater than or equal to the target? It's not, so we're not going to record the length. This is now, we've sort of restarted the problem where it was before, and now we're back to normal. So we've taken care of we've killed one of the elements, we've moved L up, and now we're moving right up as well, okay? Because we know that this does not meet the condition, so let's keep moving right up. And now we've moved right up, and we add the element to the sum. It's 4, so 6 plus 4 is 10, and 10 is greater than or equal to the target. So again, we're here. We store the length of this subarray, which is 4, using the same logic I mentioned before, r minus L is 1 plus 1. We had 4 before, right? That was our result, and we have 4 now. We're not making an improvement in terms of the minimum length. And so, we continue, and we pop off elements from the left. So it's now, we've taken 3 away from the sum, which will give us 7. And we move L up. Now the thing is that we've moved, we've taken away from the sum. Then we come back again. We ask ourselves, is the sum greater than or equal to the target? It is, right? The sum is greater than or equal to the target. The sum is 7, and we were looking for a target of 7. We said that all subarrays that are greater than or equal to 7 are valid subarrays. We want to record their length, so we end up recording the length of this subarray as well. This subarray here, 4 plus 2. Which is 6 plus 1, which is 7. And so naturally here, if we look at the indices 0, 1, 2, 3, 4, 4 minus 2 is 2, plus 1 is 3. And so this captures a length of 3, which is what we would expect. And so now, when we come to, our minimum was 4 before, but now our right minus left plus 1 is 3. So we take the lesser of the 2, and we get 3 as our new result. Okay, and we know that we want to now reconfigure ourselves to where the condition is not met to find the next subarray that meets the condition. So we end up moving left up, right? We take 1 away from the sum, which is 7. So we get 6, right? When we move L up, just as we did here. And then we end up moving right up as, and then we ask ourselves again, does this meet the condition? 4 plus 2 is 6, it doesn't meet the condition, right? And so we're fine. We can go back to moving right up again. So we move right up. We ask ourselves, does this subarray meet the condition? And it does, right? And so, we record the length, it's 3. It's not an improvement before what we had before. We still had 3. And so, we move, we subtract 2 from the sum of these elements. 4 plus 3 is 7, plus 2 is 9. And, so we would subtract 2, right? 9 minus 2 is 7. And then we move L up. Okay. And then we come back up here. Is the sum greater than or equal to the target? It is, right? This subarray is greater than or equal to the target. It's 4 plus 3, which is 7, and that meets the condition. And so we record the length of this. It's 2. Before we had 3 rather, and now we're going to have 2. And then of course we subtract 4 from it. So 7 minus 4 right? And then we move L up. And then we ask ourselves, is that sum greater than or equal to the target? It's less than, so we can move right up. And we've moved right up, and then we've satisfied this condition. Right is less than nums.length. That's falsified, and then we return. We would ideally return 2. Now the idea here is where you can rewrite this logic by saying, okay, well, if the result is equal to integer.max value, what does that mean? It basically means that we never found a result. We never reset the result to anything. So just return 0. Otherwise, you can return the result. This is just a ternary condition where you put your condition here, and you're asking yourselves, okay, is that condition true? If it is, let result be 0. If it's not, let it just be what the result was before, whatever that is. And so that's the idea behind minimum subarray length.